All right, so question 5. Um, so questions 5 and 6 are probably by far the hardest to understand. When I first looked at them, they looked like gibberish, and I had to do this with my tutor, to be honest with you. So yeah, and like even then, I had to double check with him because I didn't really understand what was happening. So yeah, in the last video, uh, we kind of thought that the answer to the question, or the way we got the answer, was like kind of scuffed. Um, so Gabe did a video uh, kind of fixing the mistake. Uh, but for this video, we actually technically we did do everything right, including the process. I just poorly explained why this was the case because I didn't really know why either. I just kind of like listened to what my tutor said. So, yeah, for the purposes of this question right now, we're just going to kind of ignore the square root. And you'll see why later. The square root is important, but we're just going to ignore it for now for the question. So, first, we're just going to factor the question, and we can common factor. So, x minus 1. That is essentially what our factor is, right? But um, before we plot anything on our graph, the square root is actually important, and it tells us what we can't have on our graph. And since the square root of a negative number would be an imaginary root, we actually can't have that as one of our. We can't have any negative numbers inside our square root. It's just how it works. So yeah, basically x cannot equal anything anything lesser than, not less than or equal to, uh less than 0. So yeah, there are two ways you can do this, and I'm going to show you guys both ways. So the way that I find to be easiest is just doing this via graphing. So uh, first, we're going to plot our x-intercepts. So they're going to be at 0 because of our x, and they're going to be at 1, right? And so this is what our graph is going to look like. It's going to look like a parabola. And so basically, for our function here, we need to find out where x is negative. And as you can see, x is negative from 0 to 1, right? And that means anything inside here is not a part of the function because we can't have a negative inside our square root. That's an imaginary number, right? So we need to include everything outside our square, outside on the positive y-axis into our domain and range, right? So the domain is going to look like xe, not curly bracket, round bracket, negative infinity, comma, 0, square bracket, and then u, square bracket, 1, comma, infinity, round bracket. And yeah, so domain is from negative infinity to 0 and 1 to infinity. And actually, um, we've got this. I also have this on Desmos as well, and as you can see, the function just doesn't exist from between points 0 and 1, which is really just the nail in the coffin to show you that that anything which is negative here between 0 and negative 1 isn't a part of the function and shouldn't be a part of the domain. So really we find the restrictions first, and then we find the function. But there's actually a second way you can do this without graphing, and this also applies to question 6, but I'm really not going to do that for question 6. Since this is all one big video, you guys should be able to figure it out yourselves. So first, we're going to kind of make a shitty table. So first, we got to add our intervals, negative infinity, comma 2, comma 0, because that's one of our x-intercepts. New column, x equals 0, new one, 0 to 1, boom, and then x equals 1, and then 1 to infinity. I'm not going to review what to do for this chart, guys. I should know how to do this algebraically in the lessons. It's kind of late for me, so if you have any questions about how to do this algebraically, just ask me. But yeah, first we're gonna have our test. So we're gonna we're gonna say it's t. Then we're gonna have x minus 1, and then f of x. So yeah, our test is just gonna be then the next closest thing to 0 is -1. It's kind of simple, but yeah. It's gonna be -1, 0, 1 over 2, 1, and 2, right? So then we have to sub in our number, our test number, into the next row, essentially. So -1 is equal to x, so that's just negative. And same thing here. Negative multiplied by a negative is a positive, so f at x is positive. For 0, if x is equal to 0, this is equal to 0. Basically cross out everything here, it doesn't matter, and it's equal to 0. For this, 0 to 1, it's going to be positive at x, but it's going to be negative at x minus 1. Positive times negative is negative. X is equal to 1. We're actually going to cross this out because x1 minus 1 is equal to 0, and we're just going to make this 0. So, and then next 2, subbing in for 2, it's positive. It's also positive for 2 minus 1. And then positive multiplied by positive is positive, right? So our positive intervals are between negative infinity and 0 and 1 and infinity. And we know that our negative interval is between 0 and 1, right? And since we know that our function can't be negative, since it's in a square root, we can't include this section into our domain. And so we get the same domain as before, xe negative infinity, comma 0, u, square bracket 1, comma infinity, round bracket. So yeah, that's how you do 5.